Graphing parabolas by complete the square can be really tedious, especially if the coefficients aren't cooperative. And if you look at this equation here, first of all, we've got this half in front of the x squared. Secondly, the middle term is 3, which is not an even number, which would make this really difficult to complete the square by. And thankfully, we have a formula which will allow us to calculate the vertex, and that way we can avoid completing the square. And using this formula instead of completing the square is analogous to solving a quadratic equation by using the quadratic formula rather than completing the square for that. So let's take a look at this problem. It says, first of all, to find the vertex of this function f of x is equal to half x squared minus 3x plus 2, and then graph the function. And we have some instructions up here for graphing functions. The very first thing says, find the direction of opening using the sign of a, which is the coefficient of the second degree term. And here we see that a, the coefficient of the x squared term, is equal to positive a half. And since this value is positive, this is going to indicate that this parabola will be face up. So we're envisioning that the parabola is going to look something like this. The second step is to find the vertex coordinates, that is x and y, or we can call them x and f of x, using this formula below. And I'd like to just rewrite the formula for this x coordinate, that the x coordinate is equal to negative b divided by 2a. And b and a are coefficients from our quadratic equation, so 1/2 is a, and negative 3 is b. So we've got a negative from the formula, negative 3 is the coefficient, and then divided by 2 times a, which is a half. And when we simplify this, the negatives will cancel, and we get positive 3 in the numerator, divided by 2 times a half is 1, and this is just equal to 3. So in our ordered pair, the x value is going to be a positive 3. Next, we want to find the y value, which we get by plugging in the value of x, which is 3. So we can find f of 3. And from our equation above, that's equal to 1/2 times x squared, which is 3 squared, minus 3x, so that's 3 times 3, plus 2. So simplifying this, we end up with 3 squared is 9 divided by 2. And we get minus 9 plus 2. That gives us 9/2 minus 7. And if we build this to a least common denominator of 2 in the denominator, we build the numerator as well. 9 minus 14 gives us a negative 5 in the numerator, divided by 2. So that value, negative 5/2, is our y value, or our f of x value. And we can put it as the second coordinate in our ordered pair. And this is our vertex. If we write it as a mixed number, so we have then 3, and then this gives us negative 2.5, and that makes it a little easier for the graphing. Now if we take this point and put it on the graph, so 3 in the x direction, negative 2.5 in the y direction, puts us right about here for our vertex. And we can also put in the axis of symmetry, because we know that the vertex is going to be, in this case, because it's a face-up parabola, it'll be the minimum point, and we will have mirror image symmetry on the right and the left. So the very last thing that we should do is to graph just one more point, and that will give us some idea of how wide the parabola is. We can have, again, a pretty good idea of what it's going to look like. It'll be a parabola going like this, but we just don't know if it's a very wide parabola or perhaps a more narrow one. So let's go ahead and plot some other point. And we're just going to choose any value of x, and x equals 0 is as easy as anything else, so let's go ahead and choose that. Again, this is our choice, and that'll give us a single point on the parabola, but when we do that, then the y value, which is f of 0, is equal to 1/2 of 0 squared, which is just going to be 0, and then minus 3 times 0, so that also drops off to 0. These two terms both drop out, and then we just get plus 2. So the y value is a positive 2 and our ordered pair is 0, 2. And this is just an ordinary point on the graph. It's not the vertex, but if we take a look over here, 0, 2 comes out over here. And so we can kind of envision what this parabola will look like. And we have a mirror image point on the other side of the axis of symmetry at the same level. And so we can connect the dots and see that this parabola will look something like this.